Hello, welcome. I'm Jeremy Clark, and here I'm going to be giving a tour of Go for the C# developer. And we can think of this as kind of a tour that you would take through an art museum. So maybe you're following a tour guide around for an hour, and they'll be pointing out some interesting things, maybe giving some anecdotes here and there. But after that's over, you probably want to go around and look at stuff yourself and maybe read all the signs and that sort of thing. So this is an overview of some things I find interesting about the Go language. And if you want to get the slides and code samples, they are available on GitHub. I'll go ahead and paste in some resource links to the Slack and to the chat. And that way you can take those home with you. You can also hit my website at any time, jeremybytes.com, and you'll find links to the resources there as well. And if you want to follow me on Twitter, I'm Jeremy Bytes on Twitter. So that's pretty much where I am online. So I want to start out by saying I am not an expert in Go. And this actually isn't designed for experts. It's designed for C# developers. And C# has actually been my primary language for quite a while. And why am I looking at Go? Well, it's an interesting language. I like getting out of my comfort zone kind of as frequently as possible, because that lets me see how other languages and environments deal with certain problems. And a lot of times there's things that I can take into my primary language. And a lot of times there's times where I say, oh, you know what? I was working with Go and it's really good at this problem that I have. So maybe I'll step out of my normal environment and go try that for a while. So in my world, why do I explore Go? Well, to see what kind of different programming approaches there are, and if there's some interesting things that I can bring into my environment. Now, I am going to spend most of the time in live code, so you get to watch me type as I show kind of some of the things I ran into as someone who's used to C# as I was learning to edit and deal with the linter and the compiler and some other things. So first, just a little tiny bit about Go. This is a language that was created at Google, and it was first released in March 2012. So it's been around a while. And a lot of times people will say, well, you know, this is good for kind of server and programmer tools and that sort of thing, but it is in fact a general purpose language. So it can be used for all different kinds of things. And it does use a C-like syntax. I'll say C-ish. And a few things about the language. It is a statically typed language as opposed to a dynamically typed language like JavaScript. Some things that were important when they were designing it, they wanted to focus on things like memory safety, so things that you don't get in environments like C. Garbage collection is also something that's built into the environment. Concurrency is a big thing, and in fact, I'll be showing some concurrency today. In order to make a method concurrent in Go, you use the Go keyword. So that's how important it is. And it was really focused on runtime efficiency. This compiles to native executables on the system. So there's no runtime or interpreter. It goes straight to native executables. And it is cross-platform. So I'm running Windows 10 today, but I've also done the same examples on Mac OS, and it runs on Linux as well. So it's a good environment for that. Today's topic, these are some of the things I'm going to hit on. And again, as primarily a C# developer, these are things that kind of stood out as interesting and made me go, I'd like to think about how this might impact my day-to-day programming. One thing is that Go does have a very opinionated syntax. So for example, where you put curly braces is important. And we'll see that when we look at the code. We'll actually see all of these things. Another thing is unused variables actually result in a compile error. So if you declare something and don't use it, you get a compiler error. So that's a best practice. You know, don't have things hanging around that you're not using. Go actually enforces that. I already talked a little bit about the baked-in concurrency. It's so just kind of a few keywords and a few concepts, and hey, I've got a concurrent application. There's another thing, which is deferred calls. And this is kind of like a finally in a try finally block in the C# world, but it kind of has a feature that I like that's a little better than that. Error handling in the Go world is completely different than C#. And I'm not going to dive into this, but if you head out to the resources, I do have an article that I wrote on this in more in depth. Basically in Go, an error is a glorified string. So there isn't this exception handling mechanism where, there's try catch blocks, and if you don't catch it, it walks up the call stack and looks for something. None of that exists. So basically we're passing these error messages around and deciding how we're going to deal with them. Go does have something that is known as a panic, which is for truly bad situations like reading beyond the end of an array or something like that. Something that's generally considered dangerous or writing to a closed channel. And in those situations, a panic behaves like an unhandled exception. The application will exit. There's no way to catch it, no way to stop it. So those are our two options in the Go world. Something else that I found really interesting is that you can have multiple return values from functions. And this is not using tuples like we might in the C# world. This is actually just like you can have multiple parameters, you can have multiple return values. And again, that's something that's interesting. Another thing is how interfaces are handled. I have a soft spot for interfaces in the C# world, and that's because it was difficult for me to learn as a junior programmer and became really useful to me in my day-to-day programming. In fact, I have a Pluralsight course on C# interfaces. That's how near and dear to me they are. Go approaches interfaces in a really interesting way through implicit implementation, which is kind of cool. And we're going to look at that as well. So that's enough talking about slides. Let's head over to code and let me show you what we're going to build. And we'll look at things from there. So I'm going to flip over to Windows Terminal, and I have some PowerShell tabs already lined up here. If you do grab the repo, then there's two folders. There's an async folder, and that's where we're going to be writing our Go code. And then there's another folder which is Net People Service. This is actually a .NET 5 service, and we're going to be consuming the service in our application. So let me flip over to my second tab. This is navigated to that .NET service. I'm going to type in .NET Run just to fire it up. And we'll take a look at what that does. Let me head to my browser and hit refresh here. And the URL that we have, see if I can make that a little bigger for you, is localhost, and I have a custom port 9874 people/1. So this is the endpoint that I'm hitting. I'm saying, hey, go to your people collection, give me ID number 1. And in this case, there's about a dozen values that are available from this service. Now, I have the completed application already in this tab, and I'll just run it so we can see what it does. So first it prints out a list of here's the IDs I'm going to fetch from the service, and then we get the values coming out of that service. Now, one thing that's kind of interesting about this is that the service has an artificial delay built into it. So each time I request one of these items, there's a 1 second delay on the server side, and that's to simulate a little bit of real world. And in this case, you notice they all come up kind of together, and it takes a little over a second to run all 9 of these requests, and that's because we're doing it concurrently. And so that's what we're going to do today. So I'll head back over to my tab that has the root of the repo and navigate to the async folder. And if I look in this folder, it is currently empty. So I'm going to start by just creating a new Go code file. And I'll be using Visual Studio Code today. And the file will be called main.go. And we'll pop this open. Visual Studio Code is a great editor for this, and Visual Studio Code is also cross-platform, so that makes it handy. One thing that makes it such a great editor for Go is that there is a plugin, an extension, I should say, that's available for Go. And this does linting as well as code completion and pop-up help and all that other fun stuff. Now, I just want to note, you might notice here that it's saying, hey, you want to update your Go extension? Well, this extension updated automatically 2 days ago. And I think there's a clash with the version of Go that I'm actually running on my machine because some of the code completion was coming out weird. So I actually downgraded my Go extension for this demo. Okay, so let's go ahead and do hello world, right? We have to start with hello world. Now, Go has everything in Go is in a package. And so we can think of a package as it's somewhere between an assembly and a namespace. So it's a unit of stuff. And for an application, the entry point for an application, it has to be in package main. And there's a function called func main, which is in package main, and that defines the entry point of the application. So we'll do a func main and get started here. So this is kind of about as empty of an application as you can get. I want to point out a few things here. So the main function that we have has a set of empty parentheses that represents parameters, and in this case, main does not take parameters. So if you're used to doing a console application, for example, in .NET, where you'll have parameters which are arguments from the command line. If you want to get arguments from the command line, there is something in the OS package where you can get to those arguments. I won't be showing that today, but that's how you would get to them since they're not passed in directly. One other thing is you'll notice that the opening curly brace is on the same line as the function. Opening curly braces must be on the same line. And this is enforced by the compiler. So like I said, Go is very opinionated about things. This is one of the things it's opinionated about. And for anyone who's done JavaScript and has run into the situation where if you don't have the opening brace on the same line and you get that empty return value thing, you understand how valuable this is. Okay, so I want to print something to the console. And there's a print function that I can use, but I need to bring in another package for that. And so this would be, similar to bringing in a namespace / assembly in the C# world. And a lot of times what I'm used to doing in C# is saying, well, I want to use a package. Instead of saying using, we'll say import. And the package I want is the format package, or FMT. So since I'm used to kind of typing and using statements at the top of my screen, I might say, okay, well, I'm going to put all my imports at the top and then start using them. Well, there's a problem, and it's not a problem once you get used to it. And that is Go, again, doesn't like unused things in your application. And in fact, the linter will do some things for you. So watch what happens when I save this file. I'll hit Control S, and my import statement went away. So when I first started doing this, I was really frustrated because I'm like, okay, import, 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 import. And then I saved it because I'm always interim saving, and everything went away. And what I learned was let it go, because the compiler, or I should say the Go extension, will take care of some things for me. So if I want to use something from the format package, I can type fmt dot, and we'll use println. And now what happens if I save, it brings in the import for me. So rather than managing imports myself, I am going to let this all happen kind of automatically. Okay, so there's a println function that goes out to the standard out, which is console by default. And we can put a hello world in there. And let's build this application. So building from the command line, you just say go build. And I'm not using any kind of debugging in Visual Studio Code just because I haven't gotten it to work, in all honesty. So I do my building and running from the command line. Now let's see what we have in our folder. So we have our main.go file. That's the code file that we just typed in. And then you'll see I have an async.exe. Now, since I'm on Windows, it is a .exe. If I was in a different operating system, it would be an executable file. And you'll notice the size of that file is kind of big. And that's because this has everything that it needs to run this application. So there's no runtime. There's nothing that's required to install on a particular machine. So I could take this async.exe file, put it on a Windows machine, and it will run. Assuming, there's always architecture and other things, x64 versus 32-bit and whatnot. But that is a complete application all on its own. And if we run it, hello world. So hopefully not too many surprises so far. One other thing that I'll point out is in the code on line 6, you'll notice there are no semicolons. So if you're used to typing semicolons, that's something you can get unused to. The nice thing is that if you do type semicolons, when you hit save, they generally go away. Semicolons can be used to separate if we want multiple statements on a single line. For example, with a for, which we'll see a little bit later. But generally, leave them out. Okay. So I'm going to show how to do some variable creations and assignments. So I'm going to create an array to hold the IDs that I want to look up from this service. And so I'll say IDs : equals. And the : equals is a creation and assignment for a variable. So it works a lot like var in the C# world. So depending on what I put on the right side of this equals, that will be the type of this IDs variable. Now, as I mentioned earlier, Go is strongly typed. It's just that it will implicitly type it based on what we have. Okay, so here's how you declare an int array. So square brackets first saying, hey, this is going to have 9 elements in it. And then we can also initialize it with a set of curly braces. So just like that. So we'll put 9 values in there. And you'll notice that I have red squigglies. Get used to red squigglies. If I hover over this, it's going to say IDs is declared and not used. And if I try to build, compiler error. So I promised you a compiler error if you have a variable you declare and don't use. Oh man, get used to it. But we'll go ahead and put this in here. And now we can build it and we will output that value. So in here, we see that we have those numbers separated by spaces in square brackets. This is a default output format for an integer array. Or actually, for any array, it would come out in that format. And we'll talk a little bit more about default formats in just a bit. Okay. Now that we've done this, let's actually make a service call. If I flip back to my service, I have this person object, and it's a collection of properties. There's some strings and integers and a date time in there in the middle somewhere. So I'm going to create a type that will have those values in it that we can use. So let's create a new type. And for this, we will say type person struct, because this will be a struct, and then we can put in the fields that we'll be using here. Now, something that's interesting about Go is that capitalization is important. Again, opinionated. So you'll notice that my type person starts with a lowercase p. My function main starts with a lowercase m. If something starts with a lowercase, it's internal to this package. If something starts with an uppercase level, it is exported from this package. So if I were to look in the FMT package, then I would see this print line function in there. Starts with a capital letter P, so it's exported, which means if somebody imports this package, they can use it. So starting with a lowercase, kind of similar-ish to private/protected in the C# world. If something starts with a capital, then it is public. Okay, so let's create some fields. So we'll create an ID field, which is an int, a given name, which is a string, a family name, which is also a string, a start date, which is a time.time, and a rating, which is an integer. Now, a couple things I want to show here. Watch what happens when I save. Bloop. Okay, first of all, it brought in another import for the time package, but it lined up my my types for my fields. So that's something that it's just doing for me. So, and then in these declarations, you'll notice that the type comes second. So the name comes first, the type comes second. Okay, so now that we have something to put, or a type to put these values into, let's make a service call. I'll make a new function. We'll call it getPerson, and this will take an ID of integer, or an ID parameter that is an integer, and I'm going to return two values. So I mentioned how in Go we can have multiple return values, and that's baked into the language. And the return values come after the parameters. So when we're talking about declaring a function, we have the func keyword, then the name of the function, then the parameters in parentheses. And if there's no parameters, then empty parentheses. And then a set of return values or return types, and then the opening curly brace. If we only have one return type, then we don't need parentheses around it. And if we don't have any return types, we don't need any parentheses. As a reminder, down on line 20, our func main, no return type. So we just kind of don't mention that at all. Excuse me. Okay, so what I need to do is call this URL and put our own value into it. So I'm going to use another function from the format package, so fmt sprintf, and then we will paste in our URL because I want to parameterize this. So rather than having a hard-coded 3, I would like the ID value in here. Now, this does use a format that's very similar to string.format in the C# world. So we have placeholders, which are called verbs in Go. The %d is for an integer value. We'll also see %s and %v a little bit later. And this is how we can generate strings. So there's a lot of printf functions in the format package. Printf means, print something that's formatted. So it potentially has these verbs in it. Sprintf will print to a string. Fprintf will print to a file, or more appropriately, anything that supports an IO writer. And then there's just a printf that will go out to the console. And so you'll kind of see this pattern as a common thing in Go. Okay, so that creates a URL that we can use. Let's make a service call. And there's an HTTP package that has a get function on it. And again, I'll save, and on line 5, it brought in net/HTTP. I actually find myself saving quite a bit because that's how you get the good help. So the pop-ups happen better if you're saving. So we can see that the get function takes a string for a URL. So we'll put that value in there. Now, what's interesting here is this returns two values. It returns a pointer to a response and an error. And this is a very similar, this is a pretty common convention for how to write your functions. You'll notice that this getPerson, I'm returning a person and an error. So the idea is that if this completes successfully, the person value will be filled in and error will be nil, which is the equivalent of null in the C# world. And so basically what we're doing is we're getting an error as one of the return values that we can then check to see if it's populated or not. Now for getting these values out, I can say, okay, well, here's response set equal to the get, but this returns two values, both the pointer to the response and an error. Well, you can assign both of those values based by just comma separating some variable names. So in this case, resp will be a pointer to a response. If I hover over this, it should show that. Yes. And is an error. And again, those are like vars in the C# world, but these are in fact separate values as opposed to like a deconstructed tuple. And I actually have an article that talks about that as well. So if you want more details on multiple return values, there's resources on my website. So we should check to see if the error is populated before we go on. So I'll check to see if the error is not nil. Now, when we're talking about if conditions, fairly similar to the C# world, one difference is there's no parentheses around the condition itself. So not equal to nil is just there. There's no parentheses. The curly brace, again, on the same line as the if. Another thing is that those curly braces are not optional. If you only have one line, you must have them. They must be there. So again, opinionated, which is good because it gets rid of some ambiguity. Now, in this case, what I've done is I've said, if there's an error, I'm going to return an empty person and the same error object. Unfortunately, I won't have time to show you doing custom error messages today. But again, I've got a link on my on the resources that talk about error handling in much more detail. For now, we'll just check to see if the error is populated, and if so, we will return it. This layout, this way of doing things is pretty common, where if we hit an error, we actually short circuit the function. So generally not an if-else situation. It's usually if this is true, exit out, go do something else. So again, kind of that's a convention that's not actually enforced, but it's out there. Okay, so now that I have a response that's coming back, I want to parse it. And for this, we'll use a JSON decoder. Now there is a JSON package, which is nice. So I can say new decoder. And again, I'll hit save just so that I've got my help populating nicely. And this is a function that takes an IO reader as a parameter. And our response object has a body. And if I look at this, it says it's a read closer. So this actually implements both the IO reader interface and the IO closer interface. So we can use that to say, hey, JSON, go ahead and decode what's in this IO reader. And then I can say .decode and tell it what I want to do with the decoded the decoded values. Now, one thing that's interesting about this decode function is if we look at the parameter, it says it is interface that has empty curly braces. Well, this represents an empty interface. So it's an interface that has no members in it. Now, because of the way Go works with implicit implementation of interfaces, which again, we'll see that a little more in person in just a moment, what this means is that this matches any type. So the equivalent of this in the C# world would be object. So if a function takes an object, we can put anything we want in here. If a function takes an empty interface, we can put any type that we want in there, and it will match that interface. Now, one thing that we do have to do is we have to get into pointers a little bit. Let me create a variable that we can use to decode our values into. Now, so far, we've been declaring our variables with the colon equals, which creates the value, or I should say declares it and assigns a value to it. You can declare a variable using the var keyword. And in this case, it's var, then the name, p, and then the type, person. Now, what I pass into this is actually ampersand p. So I mentioned that Go does have pointers. I'm sorry for those of you who thought you left pointers behind. It's actually, don't think of this as C pointers though, because again, memory safety is something that is baked into Go. It was one of the design principles. But in this case, decode does not return a person. It actually returns an error. So in order to get the values out, we need to modify the parameter that's coming in. So to be able to modify that parameter, I pass the address of that parameter using the ampersand into the decode, and now it's able to modify that particular variable. If I were to just pass p in there, it could use the values, but it could not modify it. I mean, it could modify them internally, but it wouldn't be persistent outside of the function. So kind of like an out in C#, but it's a little more nuanced than that. So it can actually assign these values. Okay, and since this returns an error, I'll go ahead and pick that up, and we'll just use a similar error block to what we used above. And then if everything is happy, we will just return a person. Oh, actually, we'll return person and nil since we have two return values. So this is the code that we need to get a value from a service. And I like that it's fairly, there's not a whole lot to it, which I like. And there's a lot of things built in, like the HTTP functions are all there, the JSON decoder is there. So, it kind of feels nice to start with. Okay, so let's use our newly found power in our main method. And I'll start by hard coding the value. So we'll say get person, and I'll pass in an ID of 3. And in fact, we'll say person error. And then we'll do a format.printf. And we'll say %d %v p.id and p. Okay. And one thing I always forget to do with printfs is there's no new line automatically on there. So \n for a new line. And what we have for this format string, again, %d is a verb that means integer. So I'm going to print out the ID. In fact, let's put a colon after it. And then %v is a verb that stands for the natural format. And we can really think of this as a toString. I could use a %s and it would have pretty much the same effect. What we have for a struct is it will print out all of the values of all of the fields. That's the default way that structs work. Now you'll see I have red squigglies and it says, hey, you're not using this error variable. Well, I'll come back and use this later, but for now, I'm going to skip over it. And I can use an underscore for that. So an underscore is it's known as a blank identifier in Go, but it's a discard. So if I'm not going to use a value, then I can skip over it. I wouldn't recommend skipping over errors, but it is possible, and will be /async. So now if we run this, now we get our values out, and it looks like I got a /n instead of a \n at the end of that. So good job, Jeremy. Okay, so \n. But what we can see is we've got the curly braces with all of the values of the fields printed out. Now I want to change that. I want it to have a different default output. And in C# we would say, oh, well, everything descends from objects, so just override the toString method and you're good to go. Well, Go doesn't have that. But it does have an interface that is used, which is called the stringer interface. And so we'll see how interfaces work for this. Now, when I'm looking things up online, I will say like golang FMT. Golang gives you better search results than Go. FMT is the name of the package that I'm looking for. And generally you hit golang.org with the documentation that you want. So that's a good way of searching. I'm going to hit the index and scroll down to type stringer, and we'll take a look at this. So stringer is an interface. And just like interfaces in the C# world, they have methods. And in this case, there's one method, which is called string with an uppercase S, takes no parameters and returns a string. Now, I kind of mentioned earlier that Go has implicit implementation for interfaces. What that means is that I do not need to mark my struct and say, hey, my struct is a stringer. I don't actually say that directly at all. What I do instead is I implement the string method on my struct, and it automatically implements that interface. So it has implicit implementation of interfaces, which is a really interesting topic that I've been exploring as I've come across different things in my programming. Okay, so let's create a func named string that returns a string. Okay, well, we have a little bit of a problem here because I need to associate this with the person's struct somehow. Now, you can't put methods into a struct. So unlike C#, I can't add a method directly to this struct. But what I can do is between the func and the string, the function name, I can add a variable and a type. And this is this associates this string method with the person struct. So, oh, and man, I'm totally having a brain freeze because I forgot what that thing is called. It's a method. Okay, I'll get back to you on that. Unfortunately, my brain froze up. Okay, so this is a method. Now, in C#, we kind of use the terms function and method a little interchangeably. People in the F# and functional programming world have much clearer definitions. In the Go world, a function is something that is not associated with a type. So in this case, function main on line 36 is a function. The get person on line 10 is a function. But on line 32, this string is a method because it belongs to the person type. And then in here, I can say return fmt.sprintf. And let's give it a %s, and we'll pass in the given name and the family name. So here's what's really cool about this. And I think it's really cool because if I look at this, all I did was add this method. And if I rebuild my application and then run it, now it comes out in a completely different format. So it comes out in the format that I want. So the implicit implementation of interfaces, I find it really interesting because all I did was add a string method and it's like, oh, well, there's an interface that matches that. And my %v format verb is going to use that. So I might get overexcited about that, but I get overexcited about interfaces in general. So, okay. Let's do a little bit of looping because loops are always important. Right now, I just have a hard-coded value, but I'd kind of like to go through all of these IDs. Now, in the C# world, we have a lot of ways to do it. We have a for, we have a for each, we have a do, or a while, we have a do while. In Go, you have a for. That's all you have. The good news is you can use a whole bunch of conditions, different condition types that actually covers the functionality of all of the different loop types that we have in C#. Let's start by using an indexer. So we'll say like a typical for loop. So I equals 0, I less than len IDs, and len is a built-in length function, and then I plus plus. So hopefully this code is not terribly frightening. And then instead of passing this in, we'll say IDs I will index into our array. So go build. And now when we run the application, we'll get all of those values coming back. Now, like I mentioned, there is a 1-second delay that's built into the service, and that's why these are clicking back slowly. We will get to the concurrency in just a bit, but we can see all of our values come out. Now, I don't like for. I like for each. For each is awesome in C#. Well, there's an equivalent of for each using the for loop in Go. First, we'll modify the way this indexer works, because using an indexer that iterates through, however long something is common. Well, instead of doing all of this, I can say range IDs, and this will have the same effect. So it will index, the I will be an index based on the range, or I'm sorry, based on the number of items in the array. And it will actually work exactly the same way. I know we've known each other for 40 minutes, but I don't expect you to trust me fully. But you can see it does, in fact, do the same thing we just saw. Now, what's more interesting than this is range can return 2 values. And in this case, I is an indexer. So again, 0 through 8 in this case. ID will be the actual value, the 1, 2, 3, 4, 5, 6, 7, 8, 9. So very much like the value that's coming out of a for each. So instead of saying IDs I can say ID. And this saves me from having to index back into that array again. So rather than, iterating through basically iterating the array and then pulling each value out, I can say, oh, give me that ID value. Now, again, it'll say I is not being used at this point, but a blank identifier takes care of that. And again, we'll just kind of do a build and a run and see that we get exactly the same results. Do you trust me yet? Maybe. Okay. So kind of the next step I want to do is I want to run these things concurrently, because this is taking too long. And in fact, to see how long it is, I'll just add a couple of variables here. So at the top, we'll say start equals time.now. So that will give me the current time. And then down here, I'll create an elapsed variable. And the time package has a since function. And so I can say time since start. And this will give me a duration. And a duration actually kind of prints out nicely-ish in the standard format. So we'll say format.printf, and we'll say total time %v elapsed. Go build. And let's do a clear and then run this. And now I'll actually wait for it to finish this time so that we can see the total time at the end, and 9 seconds is a really long time. Okay, so there we can see we've got 9.09 seconds coming out of this. Okay, now I want to run this get person concurrently. So rather than doing something one value at a time, I'd like to, kind of like think about running this as a task in C#, right? I want to run these all at the same time. And we can definitely do that in Go. Again, concurrency is baked in. And in fact, it's called a Go routine. That's how important it is. Go routines, the name of the language. That's how important these are. Now, one thing about this is now it gets complicated because how do you return something from a Go routine? Well, rather than kind of having continuations and the interesting things that we have in task and the await and so forth that makes up async await, there's a few different approaches. We can use like a shared value that can be read from different contexts. Something that is also part of the language is known as a channel. And you can think of a channel as a concurrent queue. So it's a concurrent friendly queue. So I can have an asynchronous operation that's adding things to the channel, and then I can read off of that channel somewhere else. And so that's what we'll use today. For this, I will create a wrapper around this get person, more or less. And I am really bad at coming up with names. So the best name that I have right now is fetch person to channel. And I apologize for that name. This will take an ID. Oh, it'll actually take an ID and a channel. And we'll call the channel CH, and we'll use this interesting syntax for that. And this actually won't return any values. So here I have a channel, and chan specifies the type. Channels also have to have a type associated with them that says this is what this channel will hold. So channel can only hold one type. And in this case, we have a channel of person. Now that little arrow that's pointed towards the chan, that's indicating that this function it's only going to be writing to the channel. So you can read from a channel, write from a channel, do a read and write from the channel. But in this case, we're specifying, hey, I'm only going to be writing to this channel. And that gives the compiler chances to optimize things a little bit better. And so let's take the code that we have here. We'll cut that, paste it up here. And then to write to the channel, we use a skinny arrow as opposed to a fat arrow. So what this will do is it will take that value P and put it on to the channel. And I'm not comfortable with ignoring the errors, but I want to make sure I get through the rest of this concurrency, and I'll go pick up that error if I have time. That underscore on line 37 is really bothering me right now. If you do go look at the downloaded code that's on GitHub, it does have full error handling in it. So again, this is kind of the quick tour. Okay. And this is one way of handling this. What I'm going to do is create two loops. I'm going to create a loop that will put values onto a channel, and another loop that will read values from the channel. Okay, let's get rid of that code. And outside of these loops, I'll create a channel variable. So to create a channel, there's another built-in function in Go, which is called make. And this is used to make channels as well as maps, which is like a dictionary, and also slices, which you'll want to read about slices. It's kind of it's a view into an array, and it's very common in Go. So I'll specify that I want a channel of person, and then also how big I want the channel to be. In this case, I'll say this channel is capable of holding 10 elements. This is important because if I leave this blank, this channel, a channel by default has a capacity of 1. So if I write to the channel and then something else tries to write to the channel, it will block that operation until somebody first reads that value off of the channel. So depending on what you need, that might work fine. In our case, I want to be able to put a chunk of values onto the channel so that I can read them off somewhere else. So I'll create a capacity of 10. Blocking gets interesting. And I don't have an article on this yet, but I am going to have one very shortly. Okay, so for this, we will call the fetch person to channel. We'll pass in the ID and the channel. And then to make this asynchronous, we add go. And so now this fetch person to channel will kick off concurrently, and this loop will keep going. So it won't wait the 1 second for the get person to complete. It will just keep going. So these will run pretty much in parallel. Okay, to read values off of the channel, I can create a variable, and again, I'll use the := to create and assign, and use the arrow coming off of the channel, like that. Now, in this case, what I'm doing is I'm going to, on line 48, I'm writing to the channel a certain number of times based on the IDs that I have. On line 53, I'm reading from the channel that same number of times based on the IDs. But I'm not actually using the values that are coming out. So it says, hey, IDs is declared but not used. So you don't want to do that. So another blank identifier? No, it doesn't like this either. Because it says, hey, there's no variables on the left side of this assignment operator. Well, it turns out you can leave that out entirely. So if you say for range IDs, then this will loop the number of times, in this case, 9 times, based on how many elements are in the IDs array in this case. But there's no values. I don't have an indexer or a value coming out. This is not the best way to handle this, but I want to show you asynchrony without going into all of the details because we only have 9 minutes left. Now, if you do want some more information, again, check out the resources because the sample code that's out there uses something that's known as a wait group. And a wait group it's basically a reference counter. So I can say, okay, whenever I kick off this asynchronous process, I'm going to add 1 to a wait group variable. And then up here, when this process is complete, I'm going to subtract 1 from the wait group. And then there's a wait group.wait function that you can use, and it will block, so nothing will run below it until that wait group hits 0. And so in that case, what I'd really want to do is close the channel at that point. And rather than reading the IDs a certain number of times, I would just keep reading from the channel until it's closed. So again, something I don't really have time to show you today, but something that gets a little more complicated than what we have here. But what we have here, fingers crossed, should be enough to get the concurrent operations going. Okay, I'm feeling very confident. Fingers crossed. Hey, look at that. Ta-da! Okay. Applause, applause, applause. Okay, it's a little difficult when everybody's on mute, but okay, I get the general idea. But we can see up here our time when we were doing things non-concurrently, 9 seconds, down here concurrently, 1 second. So all of these operations are running at the same time, as much as that's true in the computer world. Now, just like a lot of parallel programming, when you get into concurrency, things become non-deterministic. So if you notice the order that these IDs are coming out in, they're not coming out in any particular order. And if I run this again, they'll come out in a different order. So if that's important to you, you might need to do a little more work. But it's a standard thing we have to deal with when it comes to concurrency. Okay, so Richard Evans was actually paying attention when I was talking about methods earlier, and I just saw it in the chat. So line 32, this P person, this is called a method receiver. Thank you. Yes, that is the term that I was searching my head for. So thank you for that, Richard. Okay. So I am not going to go back and add better error handling at this point. I will leave that as an exercise for the viewer. But what I will do is I want to show you something that's kind of interesting. Okay. So if you do go out to the repository, go for the C# dev, this actually has something that is known as a code tour. And a code tour is an extension for Visual Studio. And you'll see there's a .tours folder here that's part of the repo. Let me show you what that means. Let me just pull up this code in Visual Studio Code. Code. And let's see. And then if you scroll through this code, I talked about wait groups. So that's in here. There's also the wait and closing the channel and doing things some different ways. Now, if you do have an extension, and again, you can come in here and type in code tour, and you'll find the code tour extension available. You'll see that in my Explorer, I have a code tour tab. And I have 3 tours that are set up here. And if you click this little start tour arrow, this will walk you through the code and have annotations for it. So here it's pointing at package main that we saw at the beginning, talks a little bit about that. Here we're looking at func main, talks a little bit about func main, where the curly braces go, and a lot of the things that we talked about today. This code tour is available by just, again, getting the repo and installing that code tour extension. So, and this goes into more detail than I had time to show you. And then another thing is that down at the bottom in the resources, there are some articles written, again, kind of from the perspective of a C# developer. How are things different? Loops, how do all the for loops work in Go? Defer, which I actually skipped over. I'm sorry, I skipped over defer. That's really cool. Error handling, this is an article that talks all about the error handling philosophy that's in Go. The multiple return values, which are similar to tuples in C#, but they're actually different. And then I do have some more articles that I have planned for this series as well. So there's a lot more out there. In fact, let's see how close I came. Okay, so with today's topic, we did see the very opinionated syntax, where you put your curly braces, things like that. Unused variables actually result in compile errors. Baked in concurrency, Go routines are there. Deferred calls, which I totally skipped over, and I apologize for that. Error handling, again, a different philosophy of error handling, where as a programmer, we take a little bit more of a hands-on approach, checking error return values. We saw multiple return values, and we saw interfaces with the stringer interface. There are a lot more topics. So again, this is a very quick tour, talking about how packages work. I can write custom code and bring in a package like a library. How exports work. I talk a little bit about the capitalized versus not capitalized. Project structure, types, interfaces in more detail. Named return values. You can actually put a name on your return type in addition to just the type, and bare returns go along with that. The code tour actually mentions those. The difference between errors and panics, pointers, inline Go routines, which is an anonymous function that has closures. There's a lot of really cool stuff out there. Okay, and again, here's the links. Let me just check to see if we have any. I have not been keeping a good look at the Slack. And it looks like there's no questions on either side. So in the Slack and in the chat, it looks like I'm caught up, which is kind of interesting. If you do have questions that come up later, feel free to drop me an email. Again, I'm an explorer in this space, but it is interesting to think about maybe I can use this to start writing my primary language a little bit differently. And if you go out to my website, jeremybytes.com, you will find a link to the GitHub repo as well. So if you lose track of that GitHub repo, I am Jeremy Bytes on GitHub as well as on Twitter. And so with that, I say thank you very much for spending this hour with me. And there's one session left of NDC. So enjoy the last session. And thank you very much for joining me.